Okay. And with the spinner, with the red, blue, green, black, and orange segments. So let's talk about the coin first. In the coin, there's only two choices. It's either heads or tails. So when we talk about our probability, let's say we're asking what's the probability of landing on heads the first time we flip a coin. So there's only one heads, okay, but there are two options. Okay, so that becomes 1 out of 2. Now, what happens? We'll say, okay, we're going to flip the coin twice. Okay, so what's the probability of flipping heads and heads? Okay, heads and heads on both. So again, this is the first time, 1 heads out of 2 possibilities. And then the second time we flip it, it's 1 heads out of 2 possibilities. So what do we do with these two numbers? We're going to multiply them because it's a 2-layer probability experiment. We're going to multiply the 2 together. 1 times 1 gives me 1. 2 times 2 gives me 4. Okay, so that's dealing with strictly numbers. There are several different ways that we could talk about this as well and demonstrate this. One of the other ways that we can do that is to use a table method. So in creating my table method with only 2 options, it's going to kind of look like a tic-tac-toe board. And the top, we're going to have tails and a heads possibilities for the first flip. And then for the second flip, we're going to have a tails and a heads probability for the second flip. And all this really does is to put the 2 together into each box. So tails on the first, tails on the second. So we have tails, tails. So heads on the first, tails on the second one. We have heads, tails. Tails on the first, heads on the second, tails, heads, and heads on the first, heads on the second. Okay, so we were looking for heads, heads. So we have one of those out of 4 possibilities, which is exactly what we had there. The other opportunity that we have to look at is what's referred to as a tree diagram. Okay, so with that one, I would start with the first option of a heads, and then I'd have a tails for the first flip. All right, and for the second flip, if I flipped heads in the first one, I still have 2 opportunities of a heads and a tails on the second flip. Same thing if I flip the tails. I still have 2 opportunities. I still have a possibility of flipping a heads on the second one or a tails on the second one. So again, we were looking for heads, heads, which is heads, heads. That's one of the options out of 4. So the probability of flipping a heads, heads on a coin is 1 out of 4. Now, if we were to ask ourselves what would the probability be if we flipped the coin to be the same in both times? So that's either heads, heads, or tails, tails. So again, you're looking at the numbers not necessarily work out as easy. I think the table and the tree diagram would work out the best for us to figure that out because I'm looking at heads, heads, and tails, tails. So how many different options do I have? I have 4, right? All right, and there's 4 options, and 2 of them are correct to what I'm looking for. So that becomes 2 out of 4, which gets simplified to 1/2. Okay, now here I've got heads over heads and tails, tails. So again, I've got 2 options out of the 4. So that again would be 2/4 to give me 1/2. So that's how we're going to figure our probability for something like a coin. Now, when things get a little more interesting when you're talking about with a cube, because now you've got 6 options. Okay, we've got 6 options. So let's look at just rolling a 6. Okay, what are the odds of rolling a 6 when we took a regular standard number cube? How many 6s are on a number cube? That would be 1. So we have 1 6 out of how many possible numbers are on a number cube? Now, a typical standard number cube has 6 different numbers. So we have 1/6. Okay. Now, if we said, okay, what if I wanted all the even numbers? All the even numbers. 2. How many even numbers are there? 2, 4, and 6. So there's 3 even numbers. 3 even numbers out of 6 possible rolls. Okay, so that would be simplified into 1/2. So 1 out of every 2 possibilities that I could put down are an even number. The same thing would work for odds since they're the same thing that goes back and forth. So what does this look like if we roll it twice? Okay, so what are the odds if I have the totals that add to 7? Okay, I'm going to roll the dice twice, and I want the sum to equal 7. Okay, so if I do the table diagram, okay, again, it's going to be a little bit bigger than the other one that we did. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So we create our table. Creating our table. So roll 1 here, roll 1 here, I get 2, right? 1 plus 1 is 2. 2 and 1 gives me 3. 3 and 1 gives me 4. 4 and 1 gives me 5. 5 and 1 gives me 6. 6 and 1 gives me 7. Okay? So we're going to do that for all of these. All right? So 3, 4, 5, 6, 7. 4, 5, 6, 7, 8. And 5, 6, 7, 8, 9. 6, 7, 8, 9, 10. 7, 8, 9, 10, 11, and 8, 9, 10, 11, 12. Now I have 6 by 6. So I have 36 possible solutions out of this. When I roll the cube twice, there's 36 possible combinations. And I want to know how many of them add to be 7. 1, 2, 3, 4, 5, 6. 6 out of 36. Those the only 7s? They are. All right, so we've got 6 out of 36. Can I simplify that fraction? Yes, I can. I divide the top by 6 and divide the bottom by 6, simplifying our fraction gives me 1 out of 6. So the probability of rolling a standard number cube 2 times and having the sum be 7 in any combination is 1 out of 6. Okay, so let's look at our last one. And we're looking at the spinner. And in the spinner, we have 5 different colors. All right, so what is the probability? Okay, so we have 5 different colors. So that becomes the bottom of my fraction. So what's the probability of coming up with a green? Okay, how many green sections do I have? I have 1. So it's 1 out of 5. And they're all about the same size. So that's what we'll assume the fact that they're going to be. So it's 1 out of 5. So what if I spin the spinner 2 times? Okay, what's the probability that I'm going to end up with green and then blue? Okay, green and then blue. So again, it would be really simple. We did the table there. I'm going to go ahead and use the tree diagram here. So we're going to use blue, red, orange, black. Okay, I'll put BL for black and G for green. All right, now off of each of these, we have, again, blue, red, orange, black, and green, and same thing with all of them. All right, so I have blue, red, orange, black, green, blue, red, orange, black, green, blue, red, orange, black, green, and blue, red, orange, black, and green. Okay, so I have 5, 10, 15, 20. I have 25 possible selections. So what are the possibilities of having a blue and a green in the 2 times that okay, so blue and then green. So I've got one there, and then green and then blue, I've got one there. So that becomes 2 out of 25. Those are the only 2 options that give me the criteria that I set up at the very beginning. A blue and then a green, or a green then a blue. Blue and green in each of them. Okay, so hopefully with these simple experiments, this makes a little bit of sense for you, and we'll move forward. Thank you.